Hello, I'm Anna Mackay, and today we're looking at growth and decay, and in this video specifically just at growth. So what do we mean by growth? Up until now, the types of functions that you might have been working with are linear or quadratic types of functions. These ones are exponential functions. So up until now, x has been the base, and perhaps x raised to the power of 2 or 3 or something like that. In exponential functions, x is in the power. So it's some number base raised to the power of x. And populations of animals, people and bacteria usually grow in exponential ways. So this is where these are quite useful. Let's consider a population of 100 mice. So we're starting with 100 and it increases by 20% each week. So we're going to construct the equation for that. If you're to increase a quantity by 20%, we multiply it by a multiplier. So if you were to multiply something by 1, what happens to it? It stays the same. So if you want to increase something, you have to multiply it by more than 1. And in this case, increasing by 20%, the multiplier is 1.20, if you like. So if we start with our population and we label that P subscript n, and we're saying it's after n weeks, so n is our variable, then P naught is equal to 100. So you might remember that naught as either 0 weeks have passed, or you might think of it as the letter O for the original number of mice. So there's our P naught. P1, what would that be? So 1 week has passed. We had 100 to start with, and we're going to multiply that by 1.2 to take into account an increase of 20%. So you think of that 100 multiplied by 1.2. For our second week, so that actually doesn't matter what the answer is, we're just trying to construct the formula for it. Second week, so you take how many mice you had at the end of week 1, and you're going to multiply that again by 1.2, increase it by 20%. So you take what you had in week 1 and multiply it, which is the same as doing P1 was this section here, 100 multiplied by 1.2. So take that and multiply it by another 1.2, or you've got 2 lots of 1.2. So same base being multiplied together, you add the powers. So hence why I've got to the power of 2. Taking note that we've had 2 weeks pass and it's to the power of 2. Will this pattern continue? Yes, it will. So for the third week, we take what we had at the end of the second week and multiply it again. So technically we've had 3 lots of that 1.2 and so on. So our general formula in terms of n, the pattern for that would be this. So our original population, 100 multiplied by the multiplier to the power of n, how many weeks have gone by, which traditionally we use x, but we can change the letter for the variable, that's fine. The graph of this would look like this. Just notice the scale, how you determine what that would be. Your y-intercept here is your original value, so there's that 100. I'm talking about this for when you have to draw graphs yourself and you have to think about what the scale is going to be. And then if you had a few values you could plot, you would see how far up you'd need to go and how much space to allow. So let's do a question now. Here's all of the sections, but we're going to break it down bit by bit. An entomologist monitoring a grasshopper plague notices that the area affected by the grasshoppers is given by this function, and in hectares, where n is the number of weeks after the initial observation. And we're asked to find the original affected area. That's our first part. How do we find that original one? So original means 0 weeks have passed. So instead of n, we're going to substitute in the number 0. And here was our formula. So where you see n, put in a 0. As we know, anything to the power of 0 is 1. And so our original affected area was 1,000 hectares. In worded questions, it's often good etiquette to answer with words, so in a sentence. Don't just leave it as 1,000, make sure you put the units and usually a sentence as well. Part B asked us to find the affected area after 5 and 10 weeks. So these are in place of our variable n, the number of weeks. So we're going to substitute that 5 in where we see an n and as well for the 10. As you can see there, substitute that 5 in where you saw the n, and the answer you get is approximately 2,010 hectares, and for 10 weeks, 4,050 hectares. Part C, we're asked to draw the graph of the affected area over time. So now, my advice is if you've got your calculators with you, I would graph it and create a visual picture of what it's going to be to help you out. But the key thing here is to work out what your view window would be or your scale is going to be. How to do that? Here's my suggestions. Think about your original number. So you don't necessarily have to start at 0. Here, 1000 is our original. And so that's going to be the bottom of our graph, if you like, the y-intercept. And then we're going up quite significantly. You might remember at 5 and 10 weeks what the answers were for that. You'll see them again in a minute. And what about the x-axis? So the number of weeks, how many we've had going along. They mentioned 5 and 10, so we better make sure we go out that far. Also, if you went back to the original question, sometimes that's helpful to see where you might need to go. The question might talk about something that happens in 15 weeks' time. Or the question said here something about 8,000 hectares. So make sure that your scale is going up to 8,000 at least. So here's these points that I talked about. The original is 1,000, so we would put some dots on here. Going to draw a rough graph here, and then you'll see it neatly done on the next page. And after 5 weeks, we need 2,010 hectares. So you go across to 5 on your the n axis, if you like. You label yours properly. Well, it's not y there really, it's a of n. And so after 5 weeks, we're up to 2,010 hectares. And then after 10 weeks, 4,050. So here's our 10, and you go up to 4,050. So put a dot there, and you would connect your dots with an arrow and label the function. And here it is drawn neatly. Notice the scale does go up to 8,000. Axes are labelled and arrows. You don't necessarily have to label these points B1 and B2, but it is very important to make sure you label the line. Give it a title. And then the last part of the question says, use your graph or technology to find how long it will take for the affected area to reach 8,000 hectares. Sometimes students get stumped whenever you see a number. Sometimes they're not sure which variable you substituted in for. Is it the n or is it the a? So is it the x or the y? 8,000 hectares, that's a y value, is hectares. N would, if they asked you how many weeks something was, or if it said, say, 8 weeks or something, then you substitute it in for n. So 8,000 is on the y-axis somewhere. And the technique for this is, use your calculators. Here's the first function. Notice instead of to the power of n, we're using x because that's what our calculators have. And the graph of that would look like this, depending on your view window. Now to find where 8,000 hectares is, it's saying how many weeks is that when it's 8,000? And the technique for that is to put it equal to 8,000. So in a second equation, a straight line at 8,000, a horizontal line, and we're going to find the intersection points of these two using the functions on your calculator, and the answer here is 14.88 weeks. Go back and read the question. What did it ask us? To find how long it will take. So put that as a sentence, though. It would take approximately 14.88 weeks to reach 8,000 hectares. Okay, join me in the next video for Decay. Subscribe to the channel, tell your friends. Thank you.